Well, good day, everybody. Good morning, afternoon, evening, depending on where you are. Thanks for taking the time out of your busy schedules to come have a listen to the Design Explorer updates for 2023. Let me jump right in. So I have a fairly concise list of enhancements for 2023 here that I'd like to run through. And introduce you to some of the exciting new features coming with Design Explorer. So here's just a quick overview, and we'll certainly go into each of these in a bit of detail shortly. But just as a quick overview, these are the four enhancements I'm going to highlight today, and they are from left to right there, creating responses and goals from session files. So this is a new feature that's available coming in 2023 that I think is really going to expand the possibilities for usage of Design Explorer, kind of breaking down some of the known limitations that we have with response creation today. Number two, automatic design variable linking. So this has been a highly requested enhancement from customers, and I think it's a good enhancement to helping with what is currently can be a tedious or potentially error-prone process. Number three, curve prediction, just continuing to add and enhance the various predictive capabilities that are available with Design Explorer. So curve prediction is the latest there. And then finally, Expert AI. It's kind of a big enhancement and a pretty full workflow now that I'll go into in detail when we get to that. But for those who have been following along, we've been sort of building up to this. You may recall in 2022.3, we had some enhanced clustering features that were kind of a stepping stone to the full-fledged Expert AI that is now here in 2023. So that's kind of an overview. I just kind of wanted to, I hope this will be helpful, just kind of classifying or describing each of these features in terms of what it's bringing to Design Explorer in certain areas. So some of these enhancements, and I guess this is true of any enhancement, but some of these enhancements are themselves enhancements to existing features. So we're trying to make something that you can currently do, trying to make it a little easier, a little better, maybe a little more robust or full-featured. Many of these, in fact, I think three of the four that I'm going to describe are including aspects of artificial intelligence. So I just kind of want to call that out because as Design Explorer matures and evolves, we have what I feel is a pretty solid feature foundation. We're starting to add and incorporate more and more artificial intelligence. A lot of it is in the post-processing, but even with this release, we'll see one example wherein the setup and pre-processing is made better through the use of some artificial intelligence. And I just want to call it out because I know it's a pretty AI and CAE, AI in general, but AI and CAE especially is pretty a pretty hot topic these days. So I just want to make sure to emphasize where and how Design Explorer is incorporating artificial intelligence into its workflow. And then, of course, many features are enhancements that are new and were previously unavailable. So they're making Design Explorer better, hopefully, in some new way that you can take advantage of. So I've just got this kind of diagram. I'm going to highlight this on some of the slides just to kind of indicate where the certain features, what aspects of those the features have in them. So let's go right into the detail now and talk about each of those four features in a little bit of detail. And then I've got a demonstration, mostly pre-recorded demonstrations of each of those features in action. So the first one is the responses and goals from session files. So I'm just kind of in the upper right again. I'm kind of trying to follow along with that Venn diagram. So this is an enhancement to some existing features. We introduced some generic response creation in 2022.3 so that you could add responses from result files, and this was a handy enhancement. And as I mentioned at the time, and hopefully maybe you've had a chance to take a look at it and use it. It also opened the door to being able to create responses from response types that maybe were not fully supported or at all supported in the existing workflow, that we didn't have a response tool for already. So you could do it through that mechanism. So this is kind of, in part, it's an enhancement to that. But it's also new in the way that we're doing it. And if anybody is aware of or experienced with the MDO, Multidisciplinary Optimization Director, we kind of borrowed in a way, or sort of took as that as an example, in the way that tool allows users to create and define, I think, all of their responses and goals in a somewhat similar way. So what this allows you to do is depicted here, and I'll show a quick video in just a minute. But what it allows you to do is sort of pre-specify through the use of a HyperWorks session file, where you could create any type of layout or dashboard that you wanted, and you could have plots or animations, and then evaluate responses based on what's in your session file. So you can create virtually any response that you want that way. So it certainly covers not yet supported types, or if you have combinations of results and you want to use Templex to evaluate any complex function or set of functions that you can write, then we can leverage that and allow you to define your responses and goals in that same manner. And then it's also reusable and repeatable. So you can create a bunch of responses and goals all at once, and then if you have them in your session file, you can simply reuse those if you're doing an exploration or a simulation of a similar type or kind. So let's take a look at what that actually looks like in the Design Explorer in this quick video. So what's shown here is just a simple session file where we've got some results from kind of a baseline simulation of the type that we're going to use in our exploration, and we've created a bunch of plots. And then I didn't pause quite in time, but that in that A1 cell, the very first column, so the way that this all works is it's triggered off of a table view client inside of the HyperWorks session file. And in the A1, the top left cell, that's kind of the keyword DE responses. So if we see that there, then we know that this is meant to be used to define DE responses and goals. And then just continuing on, so that first column would have your response names that you're interested in. The second column has your response evaluations. So again, in this simple example, not quick enough with the pause. In this simple example, just we plotted a result, in this case the internal energy, but you can plot combinations, of different response values on the same XY plot, or again, virtually anything that you can create using the post-processing capabilities of HyperWorks. You can do. In this example, we're just extracting the maximum value from that plot, and that's the maximum value of the internal energy. That's what we're interested in this example. But again, you can use any set of Templex functions that are needed. So the response evaluations are there. The third and fourth columns are optional. The third one, you can have your operators if you want to create a constraint or an objective. So you can have like the greater than, less than, or maximize, minimize, or min, max. And then the fourth column corresponds to any constraints that you want created, and in this case, the upper bound of 19.5. But you can have any number of these in any combination. So we've stored that, and we're going to go ahead and make use of that. So we have an optimization set up here in Design Explorer with just 4 simple design variables. But as you can see, no responses or goals are yet defined. So we'll go ahead and we'll pick the new option, which is generic response. Actually, generic response has been there, but the session file tab is what's new. We can browse for that session file that we previously created and select it, and we open that. That file is parsed, and that table view is evaluated. And then you can see in this intermediate dialog here all the response and goals that have been found in that file. So then you can check which ones that you want to actually use. In this case, we're going to check all of them, including the responses and including the goals and objective. And you can see if you select a goal, then its response is automatically selected, and we're going to create those responses. So as simple as that. We've got our 4 responses, our objective and our constraint. And then just to complete the process, let's go ahead and run the evaluate the exploration or the optimization in this case. We'll run that. And then just to show that that session file is leveraged inside the exploration, and the mappings are reworked. So any of the result files that have been used in that session file are then reused and remapped within the exploration, so that corresponding files, in this case it's H3D, and I think there's a T01 file, but whatever result files are referenced would be mapped to the various runs in the exploration, and those responses for the exploration itself could be evaluated. Okay, so next feature is the automatic design variable link creation. So this one is also an enhancement to existing features. We have design variable links, and again, you may recall, if you've been following along closely, in 2022.3, we had some enhancements to the design variable linking itself, where we added the ability to create more complex equations more easily and simply, and link different variables together in different ways. So what we've done is we've enhanced the design variable linking in this case by bringing in some artificial intelligence to help automatically create links under various conditions. And it's a very typical sort of example that we see often in the automotive realm, although I presume it has applications elsewhere as well. We're leveraging the AI that's being provided by the EDS team in the matching tool and some other shape AI tools. And this, you'll see in a second how it works, but this can certainly eliminate a lot of tedious linking tasks that would have had to have been done one at a time and manually, where you would have to identify parts that maybe are mirrored or matching parts, identify those, and then create the links one at a time. So it's also a process that's just an obvious opportunity to miss links, or to create links in error and so on. So leveraging the AI can really be a time saver, and it can also eliminate errors and things you might miss or might not notice until later. So this is a very simple enhancement, and it's exposed in a very simple way, but let's just take a look and see what it looks like. So it's here in this example. We've got a full body in white model that we're using in our exploration, and we've got I think there's 49 or 50 design variables that are being used of the various thicknesses or gauges of components in the body in white in this example. And the idea is we've got symmetric or mirrored parts, left-hand, right-hand parts, and we want to link these to ensure that their thickness values are updated consistent with one another throughout the exploration. And again, previously you'd have to identify these parts, you'd have to find them, and you'd have to go one at a time and create the links. So using this new enhancement, we can see all the DVs there. We're going to pick the new link icon. We're going to define our plane of symmetry, which in this case is the XZ plane, and then the magic happens. The AI tools go out and find all the matching parts that are matched across that plane of symmetry. We get this intermediate dialog where we can review the matches and just double check and make sure that not only are all the parts found correctly, but that we want to create links of any or all of these. And you can see there, well, can't see anymore. There was a checkbox there where we could check on or off. By default, everything is checked on. We'll create all the links automatically. But after reviewing, you could turn off or uncheck any that you don't want to have created. In this case, we left them all on, and then we can see very simply all the links have been created for us automatically. So that's that one. And again, I did just want to mention that again, as we try to add more and more AI to help with post-processing, decision making, result interpretation, we also have AI being included here in ways to help benefit users and ease exploration, setup, and creation as well. Okay, more AI. This is a brand new feature. It's an enhancement to our existing predictive capabilities. And in this case, again, said very simply, allowing users to, after you've run your exploration, your design of experiments, we can then use predictive capabilities to not only predict scalar and field predictions that we already have. We've added to that by allowing users to create to predict curves. So typical examples might be if you have time or frequency dependent values, where the response is dependent in that way. You can then, in the same way as you use all the other predictive tools, you move the design variable sliders around to set your design variables to values of interest, and then you get in real time here a prediction of a curve response. And then I just want to call out here, just noting there's a bit of a redesign of our trade-off panel here for Results Explorer. Previously, all our predictive tools were sort of stacked on top of each other, which was okay when there was only one or maybe two of them. But now as we continue to add more, we've kind of packaged them under this tabbed view here. So you can see them all sort of at your fingertips. We have one set of design variable sliders that you move around, and then in real time, you can get the different types of predictions, scalar, field prediction, and now curve predictions as well. And if there's HyperStudy users on the call, as I'm sure there are, this is leveraging the same curve prediction capability that's recently been added to HyperStudy. So I have one slide here. There is a curve prediction video. These are all very short videos, so if you'll indulge me, I'm just going to run through all three of them just to kind of summarize. Again, now with the redesign of the trade-off panel, I really feel like we now have a pretty full set of predictive features, from scalar to field to curve prediction. So let's just look at them one at a time. These are very short videos again, but just to refresh everyone's memory on the previously available predictive features, the scalar and field predictions, but then also to put in context the curve predictions and to give an idea of just the breadth of the predictive capability now. So first, scalar predictions, very simply, you move the sliders around, and then you can see down at the bottom the response values. The scalar values are being updated as we move the sliders. Excuse me. So you can get scalar predictions for any of your responses in real time. Field prediction kind of goes a step beyond that. And in this case, when you move the sliders, click the predict button and move the sliders, we get an updated entire field predicted. So we get this contour and deformed shape, in this case, being predicted as we move the sliders, again, in real time. And within the last release or two, this has been enhanced. Previously, it was available only for displacements, as is shown there. But fairly recently, it's been enhanced, so now we can support, again, virtually any of the response types or result types available: stress, strain, displacement, and so on. Okay, so those have been there. Hopefully you've seen them. Hopefully you've tried them out and you like them. But now let's look at curve prediction. Very simple to show. It works in works in essentially the same way. But now what we do is we can pick a response that has a curve. Curve, in this case, it's a time-dependent response, so it's displacement versus time, and we can move the sliders, and we see the curve update in real time. Here's our internal energy response that we've requested, and same idea. So very simple to describe and to show, but I think very powerful in and of itself, and then certainly combined with the other predictive capabilities that we already have. I think, again, we're really rounding out this set of features and predictive capabilities with Design Explorer now that we have the curve prediction as well. Okay, moving on to the fourth and final enhancement for 2023, which is the Expert AI. Before I get into that, this one is maybe a little more, I don't want to say complex, but a little more detailed in the workflow that it satisfies, and also in the mini workflow that the user performs in order to really exercise Expert AI. So before I jump into that, I've got one slide here. I've already used this slide, and this slide was provided to me by the EDS team, and Moritz, whose name is first on the slide there, is at the time, I believe when this case study was done, I believe Moritz was still with BMW. He's now a member of the EDS team with Altair. But this is some work he had done at the time, and this was presented at an Altair conference in the past. And I've used this slide to introduce Expert AI, and I used it, I believe, in the previous release seminars where we've introduced clustering tool. So you may have already seen this, but I think it's interesting to go through, and it does provide really excellent real world context for Expert AI being used at a customer in the past prior to its inclusion in Design Explorer. So what is the idea behind this expert emulation? In this example that was presented in the case study, it's a side impact example, and the goal of an optimization in this case had multiple objectives, was to minimize both weight and the intrusion into the I think this may have been an electric vehicle, so it would have been a battery bank, but it would be I think it would make just as much sense if it was a gas fuel vehicle and you were trying to minimize intrusion into a fuel tank area. But that was the idea. You want to minimize mass and a certain intrusion at the same time. So as such, when you run a multi-objective optimization, you get this typical sort of result footprint, if you will, with a Pareto front of many potentially optimal designs, each with their own trade-offs. And as noted here, often the KPIs or the performance indicators do not fully describe the crash behavior. So potentially any dark green point on that plot is a potential quote unquote optimal design. There's a trade-off, but it both minimizes weight and intrusion. However, if we look a little bit deeper, and that's what's depicted with those rail images along with the stoplights, some of these, again, optimal results deform in such a way that would be acceptable or desired, as indicated by the green stoplight, and some may not. So even though it does in a way combine minimization of mass and intrusion, we can see that rail is crumbling or bending in such a way that we risk having a puncture of a gas tank or a battery bank. So even though the optimizer has said, hey, here might be a good result for you, if we look closer, it's actually some of those are good, some are not good, and that's where the expert and expert emulation comes in. The expert would look at these and decide one is better than the other, or one is more desirable. So how can we automate that process? How can we get that expert's interpretation or indeed classification into our optimization itself? So the first thing we can do is we can provide clustering, which is unsupervised machine learning, where we tell the ML to cluster or group these results based on some characteristic, in this case, displacement. And then the clustering can occur, and again, it happens automatically, it's unsupervised, and these results can be clustered into what's shown in this middle slide as these, let's say, for example, red, yellow, and green clusters. Although red, yellow, and green initially have no meaning to the clustering tool. It just knows that based on the criteria that we've asked for, displacement, those three groups displace or deform in some similar way to one another within these three groups. So the expert then comes in and can view these clusters, given tools to do so, and determine the green one is good, the red one is bad, and the yellow one is meh. Maybe it's okay, but we would really like to have a result that both minimizes mass or weight and intrusion and lives in this green cluster. So that's a classification. Now the user has done supervised machine learning and classified these into good, medium, and bad, or acceptable, unacceptable, and so on. We can take that information, or Expert AI can take that information and leverage that as a constraint in a subsequent optimization. So now what we can do is rerun that same optimization where we want to minimize weight and intrusion, but at the same time constrain or attempt to constrain our result such that it falls into this good or acceptable deformation mode. so that we don't have the risk of the puncturing of the battery bank or gas tank. So it was in a bit of a verbose explanation, but I think that's a really great example, and it does describe really well or give some idea or context for what Expert AI is attempting to do. So I think that's already kind of a rundown of what's maybe described at a much higher level on this slide is we want to incorporate that Expert AI, those tools and workflow into Design Explorer. And obviously this one is it's new, but it's building on existing clustering capability that we have, but the ability to do the optimization and the full Expert AI is what's brand new. And of course, obviously this is incorporating even more artificial intelligence into this entire, I would say, process within a process, if you will, for Design Explorer. So what are the steps? Again, I kind of described them in the BMW slide above, but again, just because I do have a video for this, it's slightly longer than the others. It's a couple minutes long. But before I run through that video, let me just describe the steps that you'll see, which sort of encapsulate what I described in that case study. But now let's see how do we do that in Design Explorer. And the steps are pretty much as I described, but you can map that to what you see on the screen now. So the first thing you would do is you would run that exploration. The example I described, it was an optimization, and maybe that's a typical workflow or case that you would use, but it works with a DOE as well. With a DOE would generate the data necessary to train the Expert AI model so that you could do the clustering and classification. But in this example, we've got an optimization that's been set up, and it's a very similar problem to the one that was described, whereas that was a side intrusion and we were concerned with the intrusion into a battery bank. This is a portion of a front impact. We've just isolated the crash rail for simplicity and to make things a little cleaner and clearer. But we've got a front impact problem here. We've run an optimization. It's not exactly the same setup, but in this example, I believe the multi-objectives were to minimize mass, because we're always trying to do that. And in this case, I think it's to maximize the internal energy or the energy absorbed by this rail. So it's a similar setup, and I think it works for this example. So we've run that. What's shown at the bottom there is just the results of a multi-objective optimization. We've got multiple optimal runs, any of which could be a potentially optimal run that does both, minimizes mass and maximizes the energy. But now we might have some runs here, as we'll see in the example, that don't conform to a displacement that we like. So that's where Expert AI comes into the picture, and we want to leverage that in a subsequent optimization. So we open Expert AI, which is in the Results Explorer there. This had previously, it's been there previously entitled Clustering, because we had the clustering support, but not the full-fledged Expert AI. So that's what's added here, and we've rebranded it Expert AI. And you can see all the tools that are available there. Let's just step down through them one at a time and describe them very briefly, what they do and how they would be used, and then we'll show it in a video. We'll kind of actually just show going through that. But the user has to go through these steps in order to leverage the Expert AI features, so I just wanted to describe them. The first thing we have to do is we have to do what's called creating our data set, where we get our clusters, but we have to define the data set and tell Expert AI how we want the results to be clustered. So in this case, displacement is what we're going to use, and I think that's typically what I've seen in the examples that I've seen, but you could essentially cluster on any other result type as well, stress or strain or something else, if it made sense in the context of the particular problem. So we have to tell the Expert AI, we have to tell it what we want to cluster on. So displacement, in this case, we pick, this is a time-dependent simulation, so we pick a time step. We'll pick the last time step because we're interested in that final deformed shape or how it deforms. And then we do have some part filtering tools. In this example, we're just going to select all the parts in the model because we've isolated that crash rail is all that we're testing. But a larger, more typical example might be a full front impact model, but we want to down select and only do our clustering based on the based on the crash rail itself. In this case, that's all that's in the model, so we would use everything. Once the clustering is done, then there's many tools in Expert AI to allow you to visualize and evaluate your different clusters to determine not only what the right number of clusters is, but how to classify those clusters. Generically as good and bad, or however it would make sense for you to classify them in that case. Once the users leverage those tools to visualize and evaluate the clusters, and they've determined their classification, cluster 1 is good, cluster 2 is bad, and so on. Then the next step is in the middle there, where we have this train classifier area. So you would simply, once you have your number of clusters identified and you know their classification, then you just train the classifier. You'll click a button and the classifier is trained. Once the classifier is trained, then as I mentioned, you want to leverage that information. So you want to use that classification to constrain an optimization. So you'll create your constraint, and in the example shown here, we're going to say we want we want the optimal result to conform to cluster 1 with a probability, in this case, is shown there, greater than 80% or 0.8. And then finally, there's a tool there to run the optimization. And there's two types of optimizations you can run. You can run an optimization based on a fit that's been done of the during the DOE, or you can run an optimization based on running solver runs for each run in your optimization. And this is analogous in Design Explorer. Generally, we have both options for running optimizations as well. So the fit can be a time saver, but if you've run based on your fit, it's probably recommended that you would validate or verify any of the optimal runs that you get, just to double check on the accuracy of the fit. Okay, so final video, final example here. Again, just some notes on the Expert AI that we've already covered, but then a video here. This one, as I said, it's a bit longer. I actually think it may be, it's probably about 3.5 minutes. I'm just going to try and let it run, and I'll try not to say too much so we can just kind of run through it. But it's running through exactly what the example that I've just described. There's that front crash rail. We've got a front impact. We've got a number of design variables, and we're going to try and minimize mass and maximize internal energy. Optimization had been run, and we've got a number of optimal runs. We can look at the output from that optimization. Let's say we'll just plot the internal energy versus the mass, our two objectives. And we can view the Pareto front there of the non-dominated optimal runs. So we can see we're interrogating these. We can see the run number and the values corresponding to each run. So maybe we want to come back to our summary table and we want to load some results for a couple of runs of interest and just interrogate them, because we have to make a decision or a recommendation based on our optimization. What is the optimal set of gauges for this rail in this case? So we look at we interrogate these, and we can do this for any number of them. In this case, just 2 of them, but we can quickly see that there's very different deformation modes here. So the question is, how can we choose an optimal result and get the desired deformation that we want? And that's the question. The answer is, of course, Expert AI, as we've just described. So now we're just going to run right down the steps that were illustrated in the a couple slides ago where we walked through the process. So we're going to create the data set. We're going to select displacement. That final time step, as I mentioned, we don't have to select any parts because we don't need to filter any of them. So not selecting just uses everything. We're going to create our data set and get the clusters generated for us. So now we have a bunch of visualization tools. We can look on the scatter plot and see the clusters there. We can change the number of clusters, and you can see which runs conform to which cluster. So this is, again, if you think back to that BMW slide, very similar to what was done there. We can use additional interrogation tools to animate all the clusters. And this is grouping all the runs from the clusters together and just kind of overlaying their deformed shapes. So we can sort of see here the different deformed shapes that are associated with each cluster. I'm just setting the number of clusters back to 2, just keeping the example simple, but we can use any number. And there's additional tools like a dendrogram and others that are useful in helping to determine the right number of clusters. But in this case, for a simple example, let's say we've determined that for various reasons due to packaging and other factors, cluster 1 is desirable and cluster 2 is not. And we'll just take that for granted in this example. So now we'll train our classifier using the 2 clusters. When our classifier is trained, we can generate that constraint that I mentioned. And in this case, we'll say, I guess cluster 2, sorry. We'll say cluster 2 is our desirable cluster, and we want to try to conform to cluster 2 greater than 70%. So we have our constraint set. We're going to run the rerun the optimization using a solver-based optimization. We can run two runs at a time to save time. I'm just running fewer number of runs, even though it's all going to happen instantly here. Just save myself a little time while creating the example. We've run a 40-run optimization, GRSM optimization, and now we look at our results, and we find that we've got results now. If we just sort of isolate our goals here, we can see that they conform greater than, in this case, greater than 85% to that cluster, while both minimizing mass and attempting to maximize the internal energy absorbed. So that's Expert AI and the steps you would go through. I think it's a pretty neat set of features and with some really compelling real-world applications. So yeah, so that's the four enhancements that I wanted to go through. Here's just the slide we started with, just kind of repeated here, just to repeat the overview, to remind you of the enhancements that we've just seen: the creation of responses and goals from session files, automatic design variable linking based on symmetric or mirrored parts, curve prediction, really rounding out the predictive set of tools for Design Explorer. And then finally, we just went through in quite a bit of detail the Expert AI tool or workflow that's available now in Design Explorer. So yeah, that's it. Thank you very much for your attention. And I hope that I hope this information was useful. I hope you saw something that you think will be interesting and of use. And I encourage you to give a try to these and all the Design Explorer workflow features, and I hope they're helpful for you. So thank you very much.